So that last little part from yesterday or from last lesson says that sound in excess of 85 decibels can cause hearing damage. Determine the intensity of sound with an intensity level of 85 decibels. So if this is the decibel value, it's D of W. And what we want is W. All right? So we're going to start with the formula again. And that's going to be D of W is equal to 10 log W over W naught. D of W we're given is 85 equals 10 log W over the constant was 1 times 10 to the negative 12. Now, to solve, I need to first divide by 10. So 8.5 is log W over 1 times 10 to the negative 12. If this is a logarithm, what's the base? 10. So to solve this now, I'm going to say the base. Every base has an exponent. What's the exponent?
8.5.
8.5, right? It's the answer to the logarithm. Oops. To the power of 8.5. That equals this, right? That's the power. W over 1 times 10 to the negative 12. So finally, W is 1 times 10 to the negative 12 times 10 to the 8.5. And then when you can plug that into your calculator, and we get that W is 3.2 times 10 to the negative 4. And we were told up above that the unit for this is watts per square meter. Okay?
Does that say times 10 to the 8.5 or?
Yeah. 10. You just plug these into the calculator.
So you want that instead?
Yeah. Yeah.
Where do you get the 1.0?
It was a constant that was given in the problem. It's just a physical constant. It's like the speed of light or whatever. It is given to you. Yeah.
Where did you get the W over M squared? Where did you get the M squared?
So that's what I was saying is here we were told that W is the intensity in watts per square meter. Okay?
Where did the M come from?
Square meter is meter squared. So this tells you it's watts per square meter M squared. Okay, yeah.
So like that equation and the constant is given.
Yeah. Okay. And it could be that equation or it could be a completely different equation. The point is, given all of these, how do you manipulate them? Okay. Now, let's move on to 3.3. We're going to talk about properties of logarithms. Right. So we learned about this in Algebra 2. Okay. But again, we now get to the point where this is Precalc honors, and it's not about getting the answer. It's about like understanding the concepts behind them, right? So we now know that the answer to a logarithm is a what? An exponent. So if I had log base 2 of 8, what is that? 3, because I'm looking for the exponent of 2. That gives me an 8, right? So now, what if I told you log base 2 of 32? What is that? I have a 5. That's a 5 because 2 to the power of 5 is 32. So how can we write these in a different way, right? Can I write the 32 as 8 times 4? Yeah? So now suppose I had, I couldn't come up with log base 2 of 32. I don't know. But then I told myself, okay, so look, 32 is just 8 times 4. So now I say to myself, what's the exponent of 2 that gives me an 8? 3. What's the exponent of 2 that gives me a 4? 2. Together, that's a 5, right? So that's another way of me figuring out that log base 2 of 32 is equal to 5. Okay? So even though 4 times 8 is being multiplied here, when I want the total exponents, I don't multiply them, I add them, right? When I go in steps. This is where we get this property from, where it says log of x times y is log of x plus log of y. Because if I have to find, if log is an exponent, if I have to find the exponent of something that gives me a certain number, I could go in steps. I could first find, one part of it and then add it to the second part. Okay? Similarly, if I have to divide these, I gotta subtract the exponents. And we've all seen this one where if I have a power that comes down and then it becomes a coefficient. So why don't we go ahead and evaluate these? Again, these will be on a non-calculator section, right? Your test, again, it'll be like split. The majority will be non-calculator, then you will have some with a calculator. So I won't ask you, like to graph like e to the, I don't know, negative x plus 3 by hand, obviously, right? And then, word problems like number 55 here, right? Where you have to do those calculations, obviously those will be with a calculator, but things like this on this page, no calculator. Yeah. Is when you have a square root, write it in exponential form, meaning this is going to be log base 2, and then the 32, the root 32, I'm going to write it as 32 to the 1/2, right? Because that's a square root. Now, what I want to do is I want to make the base and the 32 the same. So I have a log base 2. So I want to rewrite 32 in terms of a base of 2. So it'll be 2 to the 5th times 1/2. Okay? And so now, what all this equal to is 5 over 2. Okay? On a test for these, yes, you're going to show them some work. Obviously, like even I have to write things down sometimes because, I don't want to do everything in my head. However, there is very little work to show, and I understand that. This is why it's on the non-calculator section, and this is why there is really not much room for partial credit here, right? With these ones, you either get it right or you don't, okay? All right. This next one here, I have 3 log 7, and the 49 is going to be rewritten as a 49 to the power of 1/6, right? I mean, the root 49. So now if I take this further, it's 3 log 7, and that 49 is 7 squared to the power of 1/6. And so now, don't forget the 3 here. I have a 3 times from here 2 times 1/6. Okay? And all together, that's 6 over 6, 1. And who would have thought all that mess is just a 1? Right? Now, it's very, very possible to combine steps here. Right? And yes, you can combine steps. I do this one way this year. I'll do it another way another year. But, in the end. All right, let me do a couple more and I'll take questions. So here, the 4 will come down and the 2 will come down. So I have 4 times 3 ln of e minus 2 times 2 ln of e. Ln of e we know from yesterday is 1. So here I have 12 minus 4, 8. Okay, quick pause for questions. Did you have a... Yep.
Oh, so when it says evaluate logarithm, does that mean we have to take out the logarithm?
Yeah, evaluate means get the final answer. Get a numerical answer.
Okay.
Yeah. Okay. Here, I'm being asked to expand. When you expand, here's what you have to do. You have to look inside the logarithm. So the stuff inside the logarithm, we call it the argument of the log, right? So the stuff inside the logarithm, what I do is I count how many, I call them elements, like how many elements there are, right? So here, for example, I have an x squared and I have a root e. That's a total of 2. When I expand, I need to make sure that I have 2 separate logarithms, right? So now I have here ln of something times something else. The property says I'm going to give each one its own ln and add them. So it's going to be ln of x squared plus ln of root e. Next, any exponents should come down. So this will be 2 ln of x plus ln of any square roots should be, or any roots rather, should be written in exponent form. So this will be e to the 1/2. And now that one, you can use any property you want. We've learned from the inverse property that that's just a what? 1/2. And then if you use the properties from today and move it down, it'll still be half ln of e, which is still 1/2. I really don't care how you do it, just so that in the end, you just have 2 ln of x plus 1/2. And that's good enough for us. Okay? Next, look at this one here. Again, count the elements inside. I have a cube root of x, that's 1. 36, that's 2. Y to the 4, that's 3. So in the end, I need, so in the next step here, when I expand, I need 3 logarithms. Okay? Now, so I have log base 6. Now in this case, I have some in the numerator, some in the denominator. Everything in the numerator gets a plus sign. So this will be cube root of x. Now, everything in the denominator gets its own minus sign. So, minus log 636 minus log 6 y to the 4. Okay? These are the underground people. They get minuses. Yeah.
Is it like another way to do it?
There are many ways. There at the end in your head, there's many ways. As long as in the end we have the final answer.
Okay.
So now look at this. I keep saying you need to end with that many logs, 3 logs. In this step, it's very possible that when we go further, some of the logs will go away because we simplify, we evaluate. That's cool. But we start here with 3 logarithms. Okay, now this is going to be log base 6 x to the 1/3 minus, what's this middle term? Just a 2 minus 4 log base 6 y. So here, 1/3 comes down, log base 6 of x. It's convention to put the whole number, the constant, on the end. So I'm just going to swap the order here. Minus 4 log 6y minus 2. Here we are in its full expanded form. Okay. Now, take a look at C. How many elements in the numerator? Just 1. Can I split up the 2x minus 3? I can't. I can only split up things that are being multiplied or added to with each other. I purposely leave out the parentheses here in order to stress that point. 2x minus 3 is an entity of its own. So that'll just be ln of 2x minus 3 minus ln of 3 minus ln of 4th root xyz. Okay, again, here with this bunched up stuff, there's lots of ways to do it. You could split it up before, you could split it up after. At the end of the day, all of it needs to be split up. Now, it's very, very common that a student will write this and then they'll be like, okay, I'm done. And this will get almost no credit because this little like scrunched up mess here has to be split up into 3 different terms. Okay, so this is going to be ln of 2x minus 3 minus ln of 3 minus ln of xyz to the 1/4. Okay, so now does the 1/4 come down? Yep. Tissues are all the way on that end. I saw them earlier. Oh. So now what? This is ln of 2x minus 3 minus ln of 3 minus 1/4. And now I need to split those up. So in parentheses, I'm going to do ln of x plus ln of y plus ln of z. Okay. Now, here's the deal. That, for me, will get full credit. Okay? Distributing, it's not a necessity. Like if you did 1/4 ln of x minus 1/4 ln of y, that wouldn't make a difference for me. But if this was a 4-point problem, right? And let's say you got up to this point, I might give you a point. But that's it. Because you haven't really done anything, right? Like half of it is still grouped up. Okay? If it was a 3-point problem, I'm not even sure. Okay? So, okay. All right. One more. Now we're going to condense. So everything that we did here, it's like we're going to hit rewind and everything's just, like going to go back. What was the last thing we were doing here is moving the exponents down. Now the first thing we're going to do is move the coefficients up so they become exponents. So here we go. Condense. This is going to move up and the 3 is going to become an exponent as well. So log base 4 x to the half, right, for now, and then I'll go to root x, minus log base 4 x minus 2 cubed. But now, you have log minus log. When you condense, you need to end with 1 logarithm. So this is going to be log base 4, and I'm going to have a fraction. In the numerator, I get root x. In the denominator, x minus 2 cubed. That's it. Here, 5 comes up, 6 comes up. This is ln of x plus 1 to the 5. Now, are we going to multiply or divide by x to the 6? Multiply by x to the 6. And, maybe we want to put some brackets there to make it nice and condensed. Okay. Now, the next, that's it. No. Okay, so x plus 1 to the 5 is a 6-term ordeal. We don't do that. Okay? In 10.4, we will learn how to do that with like one felt swoop. 10.4, chapter 10.4.
Are we gonna get to chapter 10?
Oh yes, we're gonna get to 12 as well.
She'll be like,
Yes.
we on 3.
We're on 3, I know.
Oh, but didn't we do some middle ones?
We did sub 4 and 5, and we're gonna do 6, 8, 9, 10, 12. Yep, not in that order.
Wait.
6, 8, 9, 10, 12, not in that order. It's all mixed up with the order. No 7. Huh? No 11. Okay, the next few things we're gonna do are not in your book. They are not in your book. Now, some years ago, for some reason, 7 to 10 years ago, these things quietly disappeared from math textbooks. I don't know why. It may be some weird conspiracy. However, they didn't disappear from calculus. So there was like a gap. It's not in the books leading up to calculus, but you got to know it for calculus. And we found that, students were struggling. So I like, scoured the curriculum, and I finally said, okay, I'll put it right here in Precalc. Okay? So we're going to do this. It's not in your book, but you got to learn how to do it for next year. That's the handout. Yeah. Okay. We're going to factor. We know how to factor when it's just, cute little x to the 4s and x to the squares. But what if we have something like this? So now, factoring follows the same principle no matter what you do, right? Let's think about what it is that we do when we factor. So if I have, let's say, 3x to the 5th minus 12x cubed, right? What can I factor out of this?
The 3.
The 3 and what else? Okay. So the 3, we know that's because it's the GCF, blah, blah, blah. That's sort of common sense to us now. And then we factor x to the what? 3. How do we know to take out a cubed or a 5th? Because you take the smaller exponent, right? You take the smaller exponent. Okay. Now, what do I write in the parentheses here?
X squared.
Okay, x squared. Why x squared? How do we get x squared? What do you do? How do you get x squared? What do you do? Okay, that's what we do. We divide. We divide back here, right? The operation to get us that is I divide by 3x cubed, the stuff that I'm taking out. But as you're factoring, do you stop and tell yourself, okay, now I'm dividing? You don't, because it's such common sense to us at this point. Like, it's so common, we don't stop and think what we're doing. But that's what it is that you're doing. You're dividing by the stuff that you're taking out. You're dividing by the stuff that you're taking out. So that's what we're going to do now. Okay. So, here. What can I factor out here? A -2 and a what? E to the x squared, right? Because those are, that's a term that they have in common. So now, what I'm basically doing is dividing by -2 e to the x squared, -2 e to the x squared. From the first term, what do I have left?
X.
Just x. From the second one,
-3.
-3,
Positive 3.
+3. And that's it. We factored. Okay? Okay. Here, I can factor out an x. Now, from the e's, look at what I have. I have e to the -4x and e to the -x. I need to factor out the term with the lower exponent. So between -4x and -x, which one's the smaller one?
-x.
-4x. It's negatives, right? So what's smaller? -2 or -8 times 2? -16. Negative 60. So negative 4x is smaller. So I'm going to factor out e to the negative 4x. So here now, I'm dividing by x e to the negative 4x. So here I get 5x, and the e goes away. Okay, minus 2. Okay, now I have the same base, different exponents that are being divided. When you divide powers, what do you do with the exponents? You subtract them, so it's e to the negative x minus 4x. Okay? So I get x e to the negative 4x, 5x, minus 2 e to the what? 3x. Because I need to subtract the exponent. That exponent minus this exponent. Negative x minus negative 4x. Huh? 2 minuses do become plus. Okay. Next one. Here, typo all the way to the end here. We're gonna make that an e to the x plus 1. Okay. No coefficients to factor out. I can factor out an x plus 1 though, right? What e to the what? E to the x minus 2. That's the smaller one, right? Between x minus 2, x and x plus 1, x minus 2 is the smallest one. So I factor out e to the x minus 2. So, from the first term, what do I have left? 7. Here, I factor out x plus 1, e to the x minus 2. So, I have 2 e to the x minus, x minus 2 like this, right? Top exponent minus bottom exponent. Okay. And then here, e to the x plus 1 minus x minus 2. Go ahead and write them down in the beginning. Better to write them down than get them wrong. I will not think you're any less of a student if you show work. So, this is x plus 1, e to the x minus 2, 7 plus 2e, what's the consensus now? Squared plus e cubed. And there you have it. We can't do anything else with that. Isn't that cool?
But you don't have to put it like in terms of like the highest degree.
No, because they're not variables.
Oh,
It's just numbers. All at the end of the day, this is all just a number. It's 7 plus 2 times 7.4 plus whatever e cubed is. Yeah.
I still do not understand when you're getting x minus x.
Okay, so here, do you know why? Okay, we're dividing, right? Okay, when you divide, what do? So if you have x to the 7 over x to the 4, you write the base, and then you do exponent minus exponent. Okay? So here too, I'm dividing. What's the base? E. And then I do exponent minus exponent. Yeah. This really should be taught in Algebra 1 when you learn how to work with exponents. And then it should be taught again in Algebra 2 when you learn how to do it. I don't know why they took it out of the books. I remember, like, they used to. It's so funny. It just happens so quietly. It's like when Facebook makes like quietly, like they make like changes to the policies and you don't know until like you get stuck with like a hack or something. That's what happens. Right? It's like, oh, didn't you know you can no longer like blah blah blah. Okay. All right. So here we go. I'm gonna factor out a 3, an x, and an e to the what? Negative 1/2. So from the first term, what do I have left? A 1. Plus. Okay, now remember, we're dividing 3x e to the negative 1/2. So here I have 3 e to the 1/2 minus negative 1/2. So it's just 1. So I have 3x e to the negative 1/2, 1 plus 3e. Now, we're never allowed to leave negative exponents in our answers. So, this little guy here, e to the negative 1/2, that's really 3x over e to the half, 1 plus 3e. But that's actually root e, isn't it? So in reality, this is all just 3x, 1 plus 3e over root e. It was e to the negative 1/2. That's why we did 1 over e to the positive 1/2.
Wait, but I thought it was, wouldn't it be 3e and then wouldn't the exponent be negative 1/2 minus 1/2? But when inside or outside? Yeah.
No, this is 1/2
Okay. Yeah, so we do 1/2.
minus 1 minus negative 1/2.
Oh, okay.
Okay. All right. So, yep.
Are you allowed to leave it e to the 1/2 on the bottom, or do you have to?
It doesn't matter. So, okay, so these two steps here are the same at the bottom. These two are the same. Now, again, with the whole, not about the answer, but about the understanding. If this was a multiple choice question on an SAT, on an ACT, on the AP test, or on a test here, you don't know which form your answers will be given in, right? So you have to be able to recognize equivalent forms of the same thing. Okay?
What math does the SAT go up to?
Algebra 2-ish. Algebra 2. And there are some stats and stuff in there, yeah. Okay. Here we go. Exclamation mark. Factorial. Okay. Yes, it's like exciting 3. Like, yeah. Okay. Like 3 factorial. That's not like 3. That's not what it is, right? It's okay. It's 3 times 2 times 1. You learn it in middle school, do you?
Yeah, I remember learning.
3 factorial is basically multiplying all the digits from that number to 1.
Oh,
Wow.
good to know. So if it's like 3 exclamation 2
Factorial,
exclamation, it's
factorial.
that times that
3 factorial.
times 2 factorial.
So times 2 times 1. Yeah, this times 2 times 1. Okay, we digress. So now, speaking of exponents, if I have x squared times x to the 6, how much is that? X to the 8. So now, if I have a to the x times a to the 2, how much is that? A to the x plus 2. We do that with no problem whatsoever. Now, if we can go in this direction, we should also be able to go in this direction. So if I have a to the x plus 2, where did this come from? It used to be a to the x times a to the 2. This is huge in calculus. not in any of the books that come before it. So, here we go. Let's split this up. E to the x plus 4. Well, that's really e to the x times e to the 4. That's it. That's all I need you to do.
E to the x1.
E to the x is e to the x.
No, that's e to the ln.
Or ln of e, yeah. Now here, I have what? E to the negative cosine x times e to the ln of 4. So, e to the negative cosine x is just e to the negative cosine x. But what's e to the ln of 4? Just 4. So this is just 4 e to the negative cosine x. Now, a little bit about negative exponents. Here, I had e to the negative 1/2. Negative 1/2 is a value. It's a negative. I know exactly that that's a negative value. So I can't have an e to the negative 1/2. I'll have to change it to a positive exponent. But when you have a negative in an exponent in front of a variable expression, right, then things change. Because it doesn't have to be negative. Depending on what, if cosine is positive or negative, this whole thing sometimes is negative, sometimes is positive. You see what I mean? So just think about cosine for a minute. Is cosine always positive or always negative? No. Half of its life, it's positive. Half of its life is negative. So that's why when it's a variable expression, we can leave a negative exponent. Okay? All right? You don't have to flip it because it's the same. Even if you had e to the cosine x, it doesn't guarantee that cosine is positive all the time. Okay. Now, homework. Homework is the book and the handout. I have a copy of the handout online, but I have some hard copies here as well.